Alright, so you're joining us for topic number 3 in Unit 1, which is going to be about midpoints and angle bisectors, but this video is only going to cover midpoints for today. We'll do this in 2 parts. Before we can talk about midpoints, I want to talk about a different word. That word is bisect, and bisect means to cut something in half. And I think another word that, or part of this word that kind of jumps out at me is like the word bi, right? Because when we think of bi, that means 2. So when I'm cutting it in half, really what I'm doing is cutting something into 2 equal parts. Okay, that's what it means to bisect something. So when we actually now look at the definition of a midpoint, the definition says the midpoint of a line segment bisects a line segment. So basically what it's doing is it's cutting in half. It's the middle point. So let's draw a picture to see if this makes more sense. Let's actually draw a line segment. Right, let's say that's AB. And on this line segment AB, the midpoint is another point that's going to lie exactly in the middle because it's going to cut AB into 2 equal parts. It's going to bisect it. Well, if we have 2 equal parts, we know they're the same length, which means they're congruent. And last video you learned when things are congruent, we can mark them with tick marks, like this. So, the midpoint creates 2 congruent segments. Let's look at an example and see how we can use this. So, looking at number 1, it says that I'm given that M is the midpoint of PQ and that the measure of MQ is 7. Before I even look at what the question is asking me, I'm going to put that information into the diagram. Okay? So the fact that I know that M is the midpoint means that this segment PQ is getting split into 2 congruent pieces. So I'm going to mark those with tick marks. And I'm also going to take the opportunity to label that the measure of MQ is 7 centimeters. So I'm going to put a 7 on the length of where MQ is, right? And now let's look at the question that it's asking me. It's saying, determine the length of PM and the length of PQ. So my goal is for my answer to say the measure of PM equals something and the measure of PQ equals something else. What's nice is since I've already done all the marking of the diagram, the problem becomes pretty quick. Because just looking at this picture here, I see tick marks, and tick marks mean that they're congruent, that they're equal. So we immediately know that the length of PM has to be the same, right? If that midpoint is cutting it in half. So I've already answered part of this question. The length of PM is 7. Now PQ was asking for this entire length from here to here. We're going to have to do a little bit more work and actually add the parts together. 7 plus 7 is 14. So the length of PQ is 14. Alright, so now we're going to apply this and do a little bit more challenging of a problem. We're going to say it's given that M is the midpoint of AB. And notice this note right here. It says mark the diagram first. Right away we know if M is the midpoint, that it bisects AB, that it's making 2 congruent segments. Okay? What we're going to do a lot, let's look at question A. It's asking for us to set up an equation and to solve for x. This is new. We haven't done this yet. Okay? And I'm looking at the difference between number 1 and number 2, and it's really in what is the measurement of the line segments that I have. In number 1, it was a number. But right here we have just 2 expressions. I don't actually know what the numerical value is of those segments and how long they are. But I do know something about them. I know that they are congruent, right? They're the same measure. So we know that they are equal. Well, we can use that to help us set up an equation and figure out x to help us understand actually how long they are. So our equation is 10x minus 4 equals 4x plus 14. I know that the length of AM is equal to the length of MB. And then we can solve for x. I can bring the x's to both sides and get 6x minus 4 equals 14. Add 4 to both sides and get that 6x equals 18. I'm going to move up here, and then I'm going to divide by 6 and get that x equals 3. So I've solved for x, right? I have an equation, I know what x is, but how do we use that to help us? Looking down at part C, it says find the length of AB. I'm just going to clear off our picture up here a little bit. I still want to leave those tick marks that I marked right away though, very first. When I'm finding the length of AB, notice that's from this all the way to here. So I want the length of the whole segment. And I think that if I knew the length of each of the parts, I could maybe add them together. But we have to figure those out first. So I can evaluate this expression, 10x minus 4, by plugging in the x value that I have and figuring out what the length of AM is. So 10 times 3 is 30. 30 minus 4 equals 26, right? So I now know, oops, sorry, I think the video paused on me. I'm not quite sure where I left off, but we know we did 30 minus 4 got 26, and now I can plug it in here, and I know that the length of AM equals 26. I should know right away what the length of MB is because of these tick marks, right? If there are tick marks, that means they're congruent, which means they're the same. So the length of MB should also be 26. But just to double check and make sure that we have the right value for x, let's evaluate. Let's plug in 4 times 3 plus, is that what it is? It's 4, yep. 4 times 3 plus 14, that's 12 plus 14, and that's 26. So we were correct. But now let's really answer the final question, because the final question, remember, wanted the full segment from A to B. So I have to add 26 plus 26. And I know that the measure of AB is 52 when we add them together. All right, we're going to look at a different type of problem. This problem where you have two things that are equal and you set up an equation by equaling things together is very common. Example 3 is going to be a little bit different, but also very common. All right, so noticing the directions in example 3, all it says that I'm given is the diagram. I don't know anything's the midpoint. I don't know anything is congruent. I have to look at this picture and figure out what's going on. So I kind of already helped us out here. We have an entire line segment. That's what I'm going to call the hole up top. That length is 24. But what we also know is that we have specific lengths of just the parts. The length of DE is 3x plus 5. And the length of EF is 5x minus 13. So I can create an equation by adding up the parts together and equaling those parts to the entire whole. So let's do that. Part A says set up an equation and solve for x. I can take 3x plus 5, that's DE, and add it to 5x minus 13, that's EF, and it's going to equal 24. So at this point what I can do is I can just combine like terms and solve for x. So I get 8x, and then a positive 5 minus 13 there is a minus 8 equals 24. I'm going to add 8 to both sides, and I think that that gets me that 8x equals 32. Divide by 8, and we get that x equals 4. So I've set up an equation and I've solved for x, and again, the point of solving for x is for us to help us find what the measurements really are. So looking at part B, it's asking us what is the measure of EF. So I want to know, I'm just going to clear off our diagram a little bit. I want to know what is the measure from E to F. So I'm going to use this expression here and evaluate by plugging in 4 for x. So 5 times 4 gets me 20. 20 minus 13 equals 7. So the measure of EF equals 7, and I have my answer there. Now what's very interesting, I really like question C, because what question C is going to ask you is, well, is E the midpoint, right? Does DE equal DF? Are those lengths equal? And one way that we can go about it is actually figuring out, well, what is the length of DE? If the entire segment from D to F is 24, And I know that EF, the part that we found, is 7. If I subtract those, I'll get what's left over, right? So 24 minus 7 equals 17. That means that DF here was 17. Are they equal? I don't think so, right? DE is way bigger than EF. So can E be the midpoint? And the answer there is no. DE is not the midpoint, okay, because E doesn't bisect, excuse my handwriting, sorry, DF. In order for E to be the midpoint, both of these measurements would have had to be equal, 7 and 7, or 17 and 17, but we don't have that in this case. So at this point, you can flip the page, but you'll watch another video that will talk about angle bisectors.